Right, Assalamualaikum warahmatullahi wabarakatuh. Alright, so this is the topic 3 of the operation research, which is the transportation programming. How to solve the problem using the Microsoft Excel, which is one of the function in Microsoft Excel is simplex. So how to solve the problem of the transportation programming using a simplex analysis. Alright, so for example, this is our data. So we have a three plan 1, 2 and 3, and we have two distributor A and distributor B. Okay, the cost of the the cost of per unit for the each transportation process is as stated, which is 10 ringgit, 25, 17, 30, 32 and 15. Alright, for the capacity, maximum capacity of the plan 1 is 800, plan 2 700 and plan 3 1000. The required demand from the distributor A and B is 1000 and 1500, and also if you see here, both capacity and required demand is equal, which is 2500. Alright, so how to solve the problem using a simplex? So the first step is copy the data for the next for the new column. Okay, so and we add in one column for the factory, and we add in also one row for the demand. So here we can create the new caption. We can call it factory capacity. Okay, or here the distributor demand. Okay, and you can clear up all these things. You can make up to make sure proper arrangement of the data. Alright, so for factory capacity, we need to insert, sorry, for the first before we insert the formula, we need to clear all the data first. Alright, so for factory capacity, must add in the formula, which is sum of the capacity for the plant 1. So same thing for the plant 2 and plant 3, and also for the distributor demand, sum of the distributor A and B. Right, and so this is what we need for the empty column here is the value we need to find. Alright, so since this is the transportation model, we need to add in the objective of the situation. What is the objective of the transportation? For the transportation, the objective is the total cost. What is the total cost? Okay, the total cost is the total summary of the data, original data, which the result will be obtained later. Alright, so how to insert the formula? The formula is a sum product of the original data, which the result will be obtained later. Okay, alright, so this is the formula we need to insert into the transportation programming using a simplex. Then how to solve the problem? Alright, so this is here what we need to find. Okay, and so what is the total cost? Alright, so how to solve the problem? We use a simplex. Okay, so go for the data, then solver. Okay, so the first thing is set the objective. What is the objective? The objective is the total cost. Okay, then what is the variable? What is changing? For second one, 2, maximum, minimum and value of. We choose minimum. Why? Because this is the transportation cost related with the transportation programming related with the cost. We choose a minimum Z. Okay, so what is the changing variable cell? Changing variable cell is what result will be obtained later to ensure the minimum cost. And so we need to add in all the formula, all the constraint if let's say we have the another formula here, we need to clear first. Okay, if let's say no formula here, you can directly create the constraint. Okay, so how to create the constraint? So add the constraint. The first constraint is a factory capacity for the plant 1, and the capacity must be less or equal than what is the maximum capacity. Okay, same thing for the second plant, must be less or equal than capacity. Then for same thing go for the plant 3, and less or equal than capacity. Okay, now we have a 3 constraint. Okay, actually we have a 5 constraint. Where is another 2? Another 2 is from the distributed demand, so we need to add another 2, so which is the first distributed demand, but here you must use the equal then what is the required demand for the distributed A. Then for the distributed B also same thing. Right. Okay, now we have a 5, we have objective, we have the changing variable cell, and so we have the 5 constraint here. Right, so next one is a select a solving method. We have a GRG non-linear, simplex or evaluatory. So for this case is you using a simplex linear programming and then solve the problem. Okay, keep solver solution, that means we need to keep the result. Alright, so now 800, we can get the result 800, 200, 0, 0, 0, 0. What is maximum capacity here? Something wrong. 200, 1000. So we need to check what is error here. F 12 13 14 12 13 14 D. Oh, okay, so the constraint here, the variable here, we need to copy all the plant, not only 2. Okay, still same thing. Why? 11,400. Check another round. D12 and E14. D12 and E14. Factory capacity 1,200. Oh, here. Where? E15. E15. DE. Okay. E15 cannot be less or equal, must be equal. Okay, DE15. Alright, and we need to solve the problem. Alright, so you can see the result now. 800, 200 and 0, 0, 500 and 1000. Okay, so the total cost is 41,400. Okay, compare with your manual calculation, which is 41,400 is same, right? So 800, 200, 0, 0, 500 and 1000. So this is how to solve the problem using a simplex. Alright, thank you very much. See you again, and Assalamualaikum warahmatullahi wabarakatuh.